This video covers some useful functions for arrays. And I have a summary table here. Min will look for minimum values. If A is a vector, it'll find the minimum entry in the vector. If A is a matrix, it'll actually find the minimum of each column. Max does the same thing as min, except for it looks for the highest value. If I compare two matrices, as long as they are the same size, min of A comma B will produce a matrix that contains the minimum of the corresponding entries between A and B, and max A comma B does the same thing. If A is a vector, sum of A will sum all of the entries in that vector. If A is a matrix, sum will actually sum down each column. And finally, find is going to find the location of all entries in an array that meet a certain conditional expression that will be enclosed within the parentheses. So let's take a look at some of these functions. If I create a vector x and I do total equals sum of x, it's simply going to add up all the entries in vector x. So I'm going to come back in this case with 15. If I do sum x greater than 0, all right, let's think about what this does. X greater than 0 will go entry by entry in the x vector and produce a vector of truths and falses. So in this case, I'm going to get 1, 1, 0, 1, 1 because all of the entries of x are greater than 0 except entry number 3, so that's the only place where I get a false. If I then put sum around that, it's going to add up all those 1s and 0s, and it's going to come back with 4. There's 4 entries in x that are actually greater than 0. I can put any kind of a conditional statement in the parentheses I want. So if I do sum 0 less than x and x less than 4, that ought to find how many entries there are in x that are greater than 0 and less than 4. And in that case, there's 2 entries that are greater than 0 and less than 4. And that would be the first 2 entries in the vector x. Don't do this. It's really tempting to do this. It's really easy to make this mistake. If I do sum equals sum of x, then sum is going to be some value, like 2 or 4 or whatever. It's going to be in your workspace. And if you try to run the sum function again, MATLAB is not going to run it. It's going to go to your workspace and it's going to pull out that variable sum is equal to 4. So remember, never, ever, ever use a variable name in MATLAB that is already a function in MATLAB, or you overwrite it. If you want to be on the safe side and never, ever use a variable name that is the same name as a function in MATLAB, you can always start all of your variable names with a capital letter, because all the functions in MATLAB always start with small letters. So let's take a look at how sum works for matrices. Okay, for matrices, if I would take the sum of a matrix, this is actually going to go down all of the columns and produce a vector of the sums of all of the columns. If for some reason I would prefer to add the rows together, I can do that by adding a second input argument into the function sum. So I can do sum matrix comma 2, and that will then sum the rows rather than summing the columns. If I actually want to sum every single entry in the entire matrix, I can run sum twice. So I can do sum of the matrix. The first one will produce those vectors of column sums, and then the outside sum will go across that vector and add all of those together. Let's look at an example of the max function. So again, I'm creating a vector of random integers, and if I do max of vector, that's going to produce the highest value in that vector, which in this particular case is 7. Again, don't make the mistake of doing max equals max of vector, because then you're going to overwrite that max function. If I want to know where the maximum is, I can add a second argument, and I can do highest location equals max of vector, and it will come back with the highest value in vector is 7, and the location is equal to 4. Now notice this only produces the first location of the maximum. I actually have a 7 sitting in entry number 4 and another 7 sitting in entry number 5. If I do max for matrices, again, it's going to find the largest value in each column. So if I do highest equals max of matrix, it'll produce a vector that shows the highest value in each column of matrix. If I want the highest value in the entire matrix, I just take the max of the max, and that'll give me the largest value in that matrix, which in this case is 93. The find command is extremely useful. It goes through an array and it finds the index or the entry number of all the entries that satisfy some specified condition. So here I have a vector C, and if I want to find where all the 3's are, I can literally do find C equivalent to 3. So I have locations of 3 equals find C equivalent to 3. There is a 3 in entry number 2, so it should come back and tell me 2. Another example, if I do find C equivalent to 1, locations of 1 equal find C equivalent to 1, there are 2 1's in this vector in entry 4 and in entry 7, so it comes back and tells me there's 1's sitting in entries 4 and 7. I can do any kind of a logical expression that I want. So I can do find C greater than 3, and it will tell me all the entry numbers in C that are greater than 3, which in this case are entry 1, entry 5, and entry 6. I can find the entry numbers where C is larger than 2 and less than 9. And that would be entry 1, entry 2, and entry 5. I can use max and find together. So let's go back to that example that we looked at before with max, and we did highest equals max of vector. But remember when we did highest location equals max of vector, it just came back with location equal to 4. It gave us the very first location where the maximum existed. So now I can use these max command and the find command together. Highest equals max of vector comes back and tells me, sure enough, the highest is equal to 7. Then I can use the find command to find where all the 7's are. So I can do location equals find vector equivalent to highest, and this time it'll come back and say, hey, I've got a 7. My highest value is sitting in entry number 4 and entry number 5. Okay, now it's your turn. Try the commands on this slide in MATLAB. See if you understand what these commands are doing. Now try these commands applied to a matrix rather than a vector.